The equation above expresses the approximate height h in meters of a ball t seconds after it's launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? So this is another quadratic equation. And just to kind of give you a visual of what this is asking, if you were to graph this, there's a ball that's being launched from the ground up into the air. It's going up, and then of course it's going to come back down because gravity happens. So this axis gives us time, and this axis here gives us height. So over time, the ball's going up, 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 and then it's going to come back down. So the question is, at what time will it hit the ground again? Right over here. So when you look at this equation, we can answer this question by solving. So we would set the equation equal to 0. So negative 4.9 t to the second plus 25t. And then we're going to use our algebra skills to solve for t. First thing we want to do here is factor out the GCF. Well, they have a t in common. We can factor that out. That leaves us with negative 4.9 t plus 25 equals 0. And remember, now we have two factors. This is a factor, this is a second factor, and when you're solving, you set each of those factors equal to 0. So our first answer is t equals 0, but this is useless because we know at the beginning, that's when the time was 0. So that's not what we're looking for. We're looking for the other time when the ball comes get back down and hits the ground. So let's continue and solve for this second factor here. So it's equals 0. We're going to start off by subtracting 25 from both sides. And we're going to end up with negative 4.9t equals negative 25. This is a calculator section, so you can plug this in. I believe this would be like around 5.1-ish. But if you just want to round this to like a negative 5, pretend this is a negative 5. Negative 5 divided by 25 is of course 5. So since the question is asking for approximately, then we know the answer is D.